and giving off of carbon dioxide from our body. In terrestrial animals, this is accomplished by breathing.
And here are Kyla Villanueva and Jessel Tolentino on their anatomy and physiology of the respiratory system and gas exchange.
Thank you, Charmaine and Jeanette. And now for the anatomy and physiology. We have the nose, the pharynx, the larynx, and the trachea. First off, we have the nose. The nose consists of the external nose and the nasal cavity. The nasal cavity warms, humidifies, and cleans the air. The nares open to the outside, and the choanae lead to the pharynx. The nasal cavity is divided by the nasal septum into the right and left parts. The nasal cavity is lined with pseudostratified epithelium containing cilia that trap debris and move it to the pharynx. Second is the pharynx, or the throat, is the common passageway for both the respiratory and digestive system. It is divided into three regions. The upper region is the nasopharynx, the middle portion is the oropharynx, and the most inferior portion is the laryngopharynx. Third is the larynx. The larynx consists of 3 unpaired cartilages and 6 paired ones. The thyroid cartilage and cricoid cartilage form most of the larynx. The epiglottis covers the opening of the larynx during swallowing. The vestibular fold or the false vocal cords can prevent air, food, and liquids from passing into the larynx. The vocal folds or the true vocal cords vibrate and produce sounds when air passes through the larynx. And the last is the trachea. The trachea or windpipe conducts air between the larynx above and the bronchi below. The trachea divides into the left and right main bronchi or primary bronchi, each with which connects to a lung. The lungs are the principal organs of respiration. Once in the lung, the main bronchi divides into the secondary bronchi, which in turn gives rise to tertiary bronchi. The bronchi continue to branch many times, finally giving rise to bronchioles. Respiratory bronchioles subdivides to form alveolar ducts that end as group of air sacs called alveoli.
And now for the gas exchange. The first process is oxygen diffuses into the arterial ends of pulmonary capillaries and carbon dioxide diffuses into the alveoli because of differences in partial pressure. The second, as a result of diffusion at the venous ends of pulmonary capillaries, the pressure of oxygen in the blood is equal to the pressure of oxygen in the alveoli, and the pressure of carbon dioxide in the blood is equal to the pressure of oxygen in the alveoli. Third, the pressure of oxygen of the blood in the pulmonary veins is less than the pulmonary capillaries because of mixing with the oxygenated blood from veins draining the bronchi and the bronchioles. Fourth, oxygen diffuses out of the arterial ends of tissue capillaries and carbon dioxide diffuses out of the tissue because of differences in partial pressure. And the last one, as a result of diffusion at the venous ends of tissue capillaries, the pressure of oxygen in the blood is equal to the pressure of oxygen in the tissue, and the pressure of carbon dioxide in the blood is equal to the pressure of carbon dioxide in the tissue.
Thank you, Kyla and Jessel. How about our ventilation and respiratory volumes for our very enthusiastic Icornidova?
I am Icornidova for the ventilation and respiratory volume. Muscles associated with ribs are responsible for ventilation. Inspiration occurs when the diaphragm contracts and the external intercostal muscles lift the rib cage. Thus increases the volume of the thoracic cavity. During labor breathing, additional muscles of expiration increases the rib movement, while expiration can be passive or active. Passive expiration during quiet breathing occurs when the muscles of inspiration relax. Active expiration during labor breathing occurs when the diaphragm relaxes and the internal intercostal abdominal muscles depresses the rib cage to forcefully decrease the volume of the thoracic cavity. Respiratory muscles cause changes in thoracic volume, which in turn cause changes in alveolar volume and pressure. During inspiration, air flows into the alveoli because atmospheric pressure is greater than the alveolar pressure. During expiration, air flows out of the alveoli because alveolar pressure is greater than atmospheric pressure. During quiet expiration, thoracic volume and lung volume decreases because of lung recoil. Lung tend to collapse because of elastic recoil of the connective tissue and the surface tension of the fluid lining the alveoli. The two factors that keep the lungs from collapsing are surfactant and the pressure in the pleural cavity. Increasing thoracic volume results in the decreased pleural pressure, increased alveolar volume, decreased alveolar pressure, and air movement into the lungs. That's all for today. Back to you, Charmaine and Jeanette.
Go. Thank you, Aiko. Here is Jefferson Sophia for our gas transported blood. Jeff.
Thank you, anchors. There are two kinds of gas transporting blood. First is the oxygen, which diffuses through the respiratory membrane in the blood. Most oxygen, or roughly 98.5% of it, is transported bound to hemoglobin. The remaining oxygen is transported dissolved in plasma. Oxygen is released from hemoglobin in tissues when the partial pressure for oxygen is low and the partial pressure for carbon dioxide is high, and when the pH is low and the temperature is high. Next is carbon dioxide, which diffuses from cells into tissue capillaries. Carbon dioxide is transported in solution as plasma in combination with blood proteins and as bicarbonate ions. In lung capillaries, bicarbonate combines with hydrogen to form carbonic acid. This acid dissociates to form carbon dioxide, which diffuses out of the red blood cells. In tissue capillaries, carbon dioxide combines with water inside the red blood cells to form carbonic acid. That dissociates to form bicarbonate and hydrogen. This promotes the transport of carbon dioxide. As blood carbon dioxide levels increase, the blood pH decreases and vice versa. Back to you, anchors.
Thank you, Chef. And now, for our rhythmic briefing is our very own Chanika Perry Hill.
The normal rate of breathing in adults is between 12 to 20 breaths per minute. In children, the rates are higher and may vary from 20 to 40 per minute. The rate of breathing is determined by the number of times respiratory muscles that are stimulated. The basic rhythm of breathing is controlled by neurons within the medulla oblongata that stimulate the muscles of respiration. Carbon dioxide is the major chemical regulator of breathing. An increase in blood carbon dioxide causes a decrease in blood pH, resulting in increase of breathing. Low blood levels of oxygen can stimulate chemoreceptors in the carotid and aortic bodies, also resulting in increased breathing. Chemoreceptors in the medulla oblongata respond to changes in blood pH. Usually, changes in blood pH are produced changes in blood carbon dioxide. Back to you, Charmaine and Jeanette.
President of World Health Organization. Good morning, Doc. Good morning. Can you tell us what are the effects of aging and exercise in the respiratory system?
As we age, the lungs become sick. Respiratory muscle strength or endurance diminishes. Total lung capacity is relatively constant across the lifespan, but vital capacity decreases because residual volume increases. Through exercise, our lungs increase their ability to expand, creating a greater quantity of air to meet breathing out. Anaerobic training tends to increase the size and strength of the respiratory muscles, but aerobic training tends to improve the endurance of the respiratory muscle. And for adaptations exercise, the effects of aging on the respiratory system will be diminished. Dr. Pedante, it was surprising news yesterday that Janet Lena Forrest died of pneumonia. Could you please explain it to us? Pneumonia is caused by many bacterial and viral infections of the lungs that cause fever, difficulty in breathing, chest pain, edema in the lungs, reduces circulation ability, and reduces gas exchange. How about our former Chief Justice Verona, who is now suffering of lung cancer? Please tell us more about it. Lung cancer occurs in the epithelial the respiratory tract, can easily spread to other parts of the body because of the rich blood release blood to the lung. Lung cancer is commonly caused by smoking. The other factors also are the big lungs that are abused and exposed. In the polluted environment, if the weak lungs are not protected, it can cause severe diseases. We should be careful to our lungs in order to prevent dangerous diseases.
Thank you, Dr. Pedante, for that informative interview you have given or shared to our listeners.
You're welcome. I'm very glad to share my knowledge and viewers. That's all for today. This is Health Today News. I'm Jeanette Carmeneses.
And I am Charmaine Santillana, hoping your news was good news.
Do you have a difficulty in breathing and you found out that you have an asthma? Try this Meptine Swing Inhaler, dry powder for inhalation and bronchodilator. And again, Meptine Swing Inhaler,